Today we're going to be disassembling a Wabco pump, the PB9008. You may notice how we have it mounted in the vise. We're going to clamp on the sides rather than damage the pilot of the flange. Joe's going to start out by taking apart. We're going to remove the transition plate assembly first. Once the transition plate assembly is taken off, we need to remove the eight nuts from the studs. You will need a cheater bar. These are torqued between 250 and 275 foot-pounds each. Once the nuts are removed, the cover plate is ready to be removed. Here you can see the position of the seals, which we're going to take out and lay back on so you can see how they are placed. Starting on the suction side of the pump, you will notice a steel isolation plate, which will need to be removed. The two steel rings are removed. And on the pressure side of the pump, there are three separate seals. Black, which is a backup ring, brown, which is the E-ring, and black or yellow would be the retainer. The pressure plate is now ready to be removed from the gear section. I'll pull it up. Notice the position of the trap. I'm going to remove the gear set. This is the rear drive gear because it has the splines that connect to the front of the pump. Removing the rear idler gear too. Now we're going to remove the second pressure plate. Now we're going to remove the gear plate itself. Hold it up. Notice the difference in the size of the two oval shapes in the gear plate. The large side always goes to suction. The small side goes to pressure. Once again, we remove the retainer and the three seals. Now we are removing the stud stabilizers, the O-rings around the studs. Hold it up. Notice the hole in the bearing plate follows through on the suction side of the pump. Again, there are 8 more stud stabilizers to remove. Remove the coupling between the front and rear drive gears. Now ready to remove the center connector plate. Okay, let's come on. Again, notice the positioning of the seals to the pressure. Remove the last set of stud stabilizers. There are 24 O-rings in all. Again, we remove the individual components from behind the pressure plate. Steel rings, the isolation plate, and the seals came off when we removed the connector plate. We are now ready to remove the studs. We are now ready to remove the pressure plate from the front gear section. Noticing again that the trap in the pressure plate points towards the pressure side of the gear housing. We're going to now remove the front drive gear. Now we are removing the front idler gear. And the gear plate. We are now down to the last set of pressure plate and seals that are against the flange. We have now concluded disassembly of the pump. We're going to show a brief view of all of the main parts that have been disassembled from the pump, starting with from the front, the mounting flange, a gear plate, connector plate, bearing plate, second gear plate, and the transition plate. Gears from the rear of the pump, the rear drive gear, the rear idler gear, 2 pressure plates. From the front of the pump, the front idler, and the front drive gear. Our next step is to show normal break-in conditions of a pump that has been tested. We now want to check the condition of the flange, starting with the bushings. With a good light, look inside and see if the Teflon coating runs 360 degrees all the way around the interior of the bushing. If brass is visible, then the Teflon coating has been eroded away. The next thing we're going to check is the condition of the lip seals. There are 2 seals. The first, which seals to the cavity of the pump. The second, which is used as a seal to the drive. Our next step is to check the condition of the 2 gears from the front section. What we're looking for here is a clean, even surface on the journals. This pump has been in a clean hydraulic environment. Notice that there is no scarring or pitting to the journals of the gears. We're looking for any wear that may be attributed to contamination, which would equal striated lines. These journals are in excellent condition. Particular attention needs to be paid to this area of the shaft. That's where the 2 shaft seals ride. Notice that it's flat, clean, there's no groove worn in it. The ends of the gear spurs check for condition. And if necessary, the width of the gears can be checked too. Size of the gear spur has been verified. We are now ready to inspect the condition of the gear plate. Again, I'm going to point out the difference between the wide oval and the small oval. The wide oval is low pressure or suction side. The small oval is the high pressure side. This area here, where I'm running my finger, is known as a gear track. That is where the spurs of the gear are pushed into the low pressure side of the housing as a result of pressure. And this pressure is controlled by a relief valve. The pump does not push the gear into the housing itself. That is the action of a relief valve that causes the gear to form the gear track. The biggest thing we're looking for here is an excessive track. Per Parker's recommendations, anything 15 thousandths of an inch or larger needs to be thrown away. But you will notice that once a track achieves 10 thousandths of an inch, performance will be greatly diminished. We're now ready to inspect the condition of the connector plate. What we're looking for here basically is the condition of the bushings again. Making sure that all the Teflon is intact. Or any damage. This connector plate is good for reuse in the condition that it is in. We're now ready to check the condition of the bearing plate, starting out with the Teflon coating on the inside of the gear journals. The coating is fine. Checking for any gross or irregular defects that may have been caused in the field. After the condition of the bearing plate has been verified, we can now move to the second gear section, which is the rear of the pump. We're now ready to check the condition of the gear set in the rear of the pump. Again, the gears, the rear idler, and the rear drive. Checking again for condition of the journals, the face of the gear spurs, and if there is any wear to the outer diameter of the gear spurs. Moving to the gear plate, we again want to examine the condition of the gear track. Now we're going to move to the transition plate. Again, like the other components that we checked, we want to check for the condition of the Teflon inside of the bushings. We want to look and see if there's been any damage to the face. We're ready to move on to the pressure plates. The critical thing with the pressure plates is that they are flat. You want to take them over to a surface plate, lay them down, and make sure they are flat. We are also looking for any severe damage to the bronze face. Here we have laid the pressure plate on a granite surface plate. We're checking for flatness. Simple way is just to lay it and tap it. This is a flat plate and is fit for reuse. What we're now going to do is show the proper way to measure a gear plate for depth of track. Using an inside mic, the gear plate needs to be measured in two areas. One, at the area at the top where the pressure plate sits and there is no gear track. The first dimension should be made there. The second dimension is this path here where the gear cuts and forms the track. We will measure this distance. Here we are showing the dimension in the untracked area of the gear plate. Write this number down. Dropping the inside mic into the center of the gear track. We will measure again. After taking this measurement, simply subtract the smaller number from the greater number, and the difference is the depth of your gear track.